Hi everyone, thank you very much for coming back. This is the second episode of our Blazor series about game development. So the last time we have started seeing how easy it is to start rendering some text on the screen using the HTML canvas wrapper that we can have in Blazor. Now, today, we're going to see how easy it is also to start rendering some sprites and some images. So the first thing that I want to point out is that if we open up the project from the last episodes and we click in the browser on F12 to open up the developer console, our canvas is not expanding to the whole size of the screen. And this might be, of course, a problem. But why is that? Is that because in our code, we have set a fixed size width and height of 300 and 400. So the first thing that we're going to see today is how we can make our canvas expand to the whole screen. So this is actually a pretty easy thing to do. The first thing that we have to do is we get rid of the sides here. And honestly, I don't like the ID that we have here. So we change to something a little bit easier. Canvas container, for example, because this is actually a container for a canvas. Then we go back into the index that we have. And so the idea is that we need to handle the resize event on the window. So the first thing that we're gonna do is we need to get a hold on our canvas, and in order to do that, the first thing that we do is we find the canvas container. Canvas container accessing the document.get element by ID, and we have used canvas container here. Voila. And then we get from the canvas container the list of all the canvases that we have here, like this canvas container, by taking all the elements with the same tag name, which in our case is canvas. Now, this list might be null or empty, so I just want to put a safety net on top of this. Now, at this point, we will have to enrich the instance that we have here. So we cannot use just the instance. We need more stuff on this. So what we do is we change the way this object is built up. Game, and what we do is instance canvas, and we take the canvas at this point. Canvases dot length. Do we have something here? If so, we take the first element because that's the only thing that we want. Otherwise, we take a null, and that's it. Now, of course, there will be something to change here, but the idea is that game, and we keep invoking the game loop, but at this point we will provide game.canvas.width and game.canvas.height. Okay, that's the point. That's goal. We will pass the width and the height to the game loop. We are going to use them afterwards. Now, the next step will be to handle the resize. So what we do is function on resize. We create an event handler. And of course, we need to make sure that we actually have something. We have a canvas. So if we don't, okay, canvas. If we don't have a canvas, we just return. These will happen in case the init game method has not been called yet. Now, the next thing that we want to do is we need to resize our canvas with the width. We will set it with window dot inner width. Basically, the canvas will expand to cover the entire window, and we do the same with the height. Okay, there we go. And at this point, we need to not only call this method at the very beginning, but we also need to register it. Window dot add event listener as resides and on resides. Now, this is still not enough. Um, if we go back to the index here, we wanted to provide it here int width, int height. Okay, here we go. And we can get rid of this 300 here and 400 here. Now we can build, go back to our browser, wait till the build is completed. Okay, here we go. We can reload the page. And if we inspect the canvas, we get, as you can see here, width and height expanding. And the other thing is that if we resize, width and height are changing. Okay, this is super important. Now, we are clearing up, and honestly, there should be some text rendering here. This is funny. Okay, window game is not a function. Oh yes, of course, of course, of course. See, the problem is that we don't really have a way to debug in Blazor WASM. Actually, it's not really working. At least not for me. I was not able to set it up properly. So it's more a matter of trial and error. I made a mistake. I was calling the interrupt methods on the game instance instead of the actual game, and I'm still doing that. Cannot read property of undefined window of dot. Oh yeah, game dot instance. Okay, here we go. Now it should work. Yes. Okay. So as I was saying, now the canvas is expanding, is fluid, and we can resize the window, and the canvas will keep expanding. Now, this is funny, but text is not exactly super interesting. So what we want to do now is we will start rendering some stuff. So I'm going to create a new folder here in the www root, and I call it assets, and I will drop an image. I'm going to use the Blazor logo. So just going to drag and drop an image here. Here we go. We got this Blazor logo here. Okay, here we go. Now, the next thing that we have to do is we need to reference like a regular image here. EMG and C sources, assets, the Blazor logo. We don't want to show it on the screen as an HTML element. We need to render it in the canvas. So we will hide it. And of course, in order to access, being able to access it, we need a reference. And we will call it Sprite. Now, we can access it using the element reference Sprite class. Okay, here we go. Then, this will be actually pretty easy. I will just add a new call here in the game loop, await context dot draw image async. We will pass the sprite, and a position in this case will be the top left. And now for the sides, we'll just pass with an height divided by 2. I'm going to show you why. Okay, let's build. Wait till the build is completed. I don't need the developer console anymore. So, okay, and here we go. Let's see what happens. Okay, so what we have is the Blazor logo being rendered on top of the text. This is because the calls here happen one after the other, so elements will overlap. We will handle this thing in another session, but for now we will keep it as it is. Now we managed to render an image, but this could be enough for us, or maybe not. So there's a few things that I want to work on. Um, First of all, the image is pretty static, so I would love to move it, and we are not really using the sides of the image as it is. So let's work on that. The first thing at this point that we have to do is let's define a class holding our sprite, okay, the sprite information. So what we will do is I'll just add a new class here, add class, and I will call it sprite. Okay, here we go. My computer is acting pretty slow today. Come on, do something. Perfect. Okay, and yes, I see what's the problem. Okay, perfect. Now, what we want here is, first of all, we need to hold the sprite reference, public element reference, and I will call like image ref get and set, and then I will add the sides. Now, usually in video games, we try to pre-compute everything. So the sides, we know it already how big is the image. So we can simply load it directly. We can either parse the image, load it with whatever library we have, and extract the actual image size, or we can create like an asset file containing a list of all our assets with their metadata, and that will be another option. I will go with that way, but we will see it in another episode. So what we will do is once we have this sprite class, we will do something like this: sprite, and let's give it a proper name, Blazor logo. Okay. Now we need to instantiate this after we have initialized our game. This way we are also sure that we have a proper reference to the actual image here on line 18. So we'll do blazor logo.new sprite, and we do image ref equal to sprite, and we get the sides. Now the image that we have is 750 pixels squared. You know what? I'll just use 200 and 200 today. Okay. Now we go here, and instead of rendering the actual sprite, we use Blazor logo reference. It will be exactly the same, but it will help us later on. And instead of using the screen sides, we will use the actual image sides. So sides dot width, Blazor logo, sides dot height. Build, refresh. Oh, this is interesting. Here we go. Here we go. Now the image is rendered with the proper sides. Well, it's not the actual sides, but you got the point. It's a squared image. Now, the next thing that we're going to do is we're going to refactor the code a little bit, and we're going to make the sprite move across the screen. So uh, one good approach is to have an update method and a render method. Basically, what we want is to separate the logic, the update of the logic from the actual rendering part. So I'm gonna just extract all this code into a render method here. Okay, and I'm gonna use a value task. Whoa, value task. Okay, and then we will need another thing. We cannot just simply use the timestamp at this point. If we want to keep consistency the animation, we need to keep track of the time in a proper way. So the next thing that we're going to do is we're going to create a game time class. Now this game time class is going to expose public float total time, which is exactly what we have already, and public floats like sprite time, um, frame time, which is basically the time that occurs between the current frame and the previous one. We will need that for our calculations. So I will call it like elapsed time, get and private set. How are we going to compute that? Because we're going to use a private for our total time, and this will be just a property with a getter returning our total time, and in the setter we're going to do this dot elapsed time equal to the current value that we have plus what we stored, and then we update the stored value of total time value. Here we go, perfect. Okay, we're going to refactor. Go to game time. Okay, perfect. We create at this point a reference in our page. Game time equal to new. Okay, and then every time we do a rendering, we render. Every time we render, we update the total time. So here in the game loop, actually not when we render, at every step of the game loop. Game time is total time. We have the timestamp, so we just assign it. At this point, I don't want to provide this parameter here anymore because I have it. And elapsed time, let me change these to frame time. Let me build. Oh, whoa. Oh, yes, of course. Forgot to remove the argument. Here we go. And refresh. I should probably move this image somewhere else so we can see the change. Yeah, you know what? I will put a 100 here, or maybe no, I will leave this as a 0 or a 20, 100, and move it. So I will just offset it a little bit so we can read the text. Come on. And there we go. We have 16 milliseconds between each frame, which is not too bad. Okay, now the next thing. We want to move that sprite across the screen. So what I'm gonna do is I'm gonna make the sprite bounce, and basically when it hits one of the walls, the four walls of our window, it will just bounce and change direction. So in order to do that, we need a few things. We need to keep track of the position, we need to keep track of the direction, and we need a speed that in this case we will just keep constant. So let's start from that. I will add a float Blazor logo speed, and I will set it to this value. Then I will need a point representing the position. and for now it will be 0, 0. And then I will need another point representing the direction, which I will set it to new point 1, 1. Okay, now you can use these things straight away, and that's log.position.x, log.position.y. So what happens is that we are already telling the system to use this value, the Blazor logo position, to store and to render our image. Now, if I build, I'm expecting the Blazor logo to go back into the top left corner. See what happens. There we go. Okay, now we need to update our state. So in order to do that, we create a new update method here. Private async, oh, come on, async value task, update, and now the thing is, I want the logo to bounce, so we need the window size. So what we'll do, we will pass it here. Same thing that we're doing with the render. Let me start to call it already, otherwise I'll forget it probably later on. So in order to make it bounce, we need to check the current position, and we will also check not only the position, but also the sides of the sprite. Let me start writing it. So position.x plus logo.sides.width is bigger than the width, or position.x is below 0. Basically, if we are going too far on the right or too far on the left, we invert the direction on the x. And we do the same thing on the other axis. So y, this becomes height. There we go. And then at this point, what we do is we update the sprite position. So x equal to what we have here is the speed multiplied by the current direction that we have on the x multiplied at this point the game time. And we need the time between frames in order to keep the computation consistent. Now, this is a float and this is an int, so we will need a cast to integer. And we do the same on the other axis. There we go. Let's build. Okay, and refresh. And let's see what happens. It's stopped. Okay, now why is that? You're supposed to be moving. Oh yes, because we need to add, not just set. My bad. Sorry. Let's rebuild, refresh, and we don't have a sprite anymore. Okay, here we go. Perfect. And as you can see, it's bouncing. The nice thing is that since we are providing dynamically the sides of the screen, this will react if we resize the window. I find it quite relaxing, honestly. Okay, so this concludes the episode for today. I hope you had fun. And next time we're gonna move on and refactor a little bit the code that we have, because this is a good start. And yes, so thank you very much to everybody who attended the session, and see you next time. Bye.